All right. Okay, so we looked at last time is word count, right? So what we did was we did WC text dot file, and I explained you it has 23 lines, okay, and 176 words, 1260 characters. And this is the name of the file you're looking into Word. So now 23 lines is fine, right? If you do cat and if you do text file one, that is fine. It will just come up without any issue. Okay, now the thing is, normally these are not just few lines you would have in your configuration file or any text file you have. You would have like thousands of lines there. For example, if I do cat log the messages. Mm, Give me 1 second here. I'm checking one system file here and look at this. This system file has 4,000 lines in it. And if you could just do simply cat, it's going to be very painful stuff, right? It has a lot of lines in there and it's flew by so fast. So for that, what you do is you use the head command. You do head and text file one. So what the head command does is, okay, if I could type it correctly. So what a head command does is it brings up first 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. Okay, so what it does is it will help you read it better, or you could manipulate the output. So what the head command is this command will read the file, but output will be 10 lines. So this command will read the file. You can use the head to many lines as possible, but we'll start from the first line. So if you do cat text file, so it starts from the top here. And it's going down this way. And it's gonna what it does is it will read from the top. So if you do head hyphen 15 and this, so it reads top 15 lines starting from top line here. Okay, so this is how you use the head command. What if I want to use only 5 lines? You give head hyphen 5. So what will happen is this is how you would manipulate this here. Okay, so let me put this here. Shows top 5 lines. Okay, and so you get the idea. This one shows top 15 lines. Okay, this is how they do these things here. Now, what about if you want to read on the bottom of the line? So there is a command that goes from the bottom. This one will be the starting line and it goes up. So for that, tail. You have head, for this you have tail. And you see, by default it goes up, 10 lines going up. So some files, when files are writing to the, when system is writing to the files, it writes to the bottom of the file, okay? What it does is it writes to the bottom of the file. Um, that way you could read the activity which is going on the bottom of the file. So if I have, what I could do is I use this here, or I could do, let me do one system file. But before that, let me put the output for this. So it reads bottom 10 lines by default. You could add a switch. That means same thing like head, If you do tail hyphen 5, you see bottom 5 lines. Or if you do tail hyphen 15, you do bottom 15 lines going from bottom up. Head was top down, tail was bottom up. Okay, so this goes bottom 5 lines. Excuse me. And in this example, you have bottom 15 lines. So if you want to see bottom 100 lines, you just make it 100, okay? So for example, you could do like sudo cat, no, not cat, tail. Um, there is a system config file. No, I'm sorry, not system security activity file, which is called warlog secure, right? It's write down the security information there, and you put down Red Hat. So this one is doing by default, it is reading last 10 lines of this file here. Let me clear this. So it's reading this last 10 files here, right? Now if I go down here, if I read here, so looks like this one is actively changing. See, last time it was here. Now this line has been changed and we have like extra 3 lines from last time. So for you to see the live activity for the specific file, what you do is you do tail hyphen F as in Frank and hit enter. So you see here that there is some activity going on in here. So let me do one thing here. Let me let me connect another session here and you would see the activity is getting updated here. Okay, I did some activity in the background and looks like it is some stuff is happening here. I put in, I tried to log in as root and stuff like that. That is happening here. See, there is on this computer. Somebody from your side disconnect and connect again and see what happens here. Okay, somebody is connecting. Hmm. Somebody filled the password, disconnected, invalid, check password. Is somebody doing that? So, so the moral of the story here is you could use tail hyphen. You could use um, tail hyphen F to see the live activity here. Okay. So this is a very good tool for you to use. All right. So any questions now? All right. So let's move on. So now next item we're going to work on is sort. Okay. So let me do cat text file one. And there is a command you call sort. Okay. What it does is it will sort the output in the alphabetical order. Okay. So the problem here is it did it in alphabetical order. See, total was on top. What it did was it brought it down where it's supposed to be, T, and name Zafar is on the bottom here. So what I'm gonna do is let me create a file via text file. No, I'm gonna give it a name sort file. Okay. And then what I'm going to do is I'm going to type Z, Q, A, B, D, F, R, P, Q, M, I, D. Okay. Another D, another C, C. Okay. So let me just save and exit. And if I type sort and a file name, what it does is it sorts it alphabetically. So even though file is in different form, it sorts it by looking at very first letter of the line. So it sorts it A, B, C, C, D, D. So it does it in the order here. So now you could do it in descending order also, I think. So for that, I normally don't use this often. I'm going to go into um, man pages. So these are files you go in, check it out for using. If you want to use the command, but if you want to use something different here, there's a lot of flags you could add here. So random reverse, okay. Sort hyphen R, reverse the result of comparisons. Okay, let's see if that is going to work. So I'm going to do sort hyphen R, sort file name. So what it did was it did in a reverse order. So sort file one. All right, so if you use sort, let me just put it in here. Sort hyphen R, sorts in reverse order. All right, so the next command we're going to use is awk. AWK. So what awk command does is it will sort it out. So let's take a look here. Get all the files. Okay, so I have this file here, right? What I want to do is I want to display, in reality, this is column one, okay? And let me show you what. Okay, in reality, from here to here is column one. This is column two. This is column three, four, five, six. So what I want to do is I want to just cut the columns. Okay, especially I don't want to see this column here. I don't want to see this column. I don't want to see this column. I really don't like that. So what I'm going to do is I'm going to use the awk command. So how I'm going to use is pretty simple here, but sometimes you get carried away how to use it, but it should be simple using this awk command. So what I will do is I will type awk, okay? And this is the formula here. You do curly brackets and then you put curly brackets into single quotes, okay? And in between here, you type print. Okay, so this is the format formula. So you do awk and then you do print here. Okay, and then you want to tell which column you want to print. So this one is column 1. I don't want that. And then this is column 2. I don't want that. And then this is column 3 and 4. So what I want is I want column 3, 4, 5, 6, 7. So this may be touchy here. It may think this is a different column here in between, but we'll see here. So, but for now, what I'm going to do is I want only column 3 and 4. And I want column, let's try 3 and 4. So for that, what you have to do is you have to type dollar and 3. And then I want to type dollar 4. And then now I give the name of the file also. You want to tell the system which file you want to awk. And there you go. You see here, it has clear output here. It removed everything else, so it brought in this column and this column. Okay, so here, is the space gonna, no, there's for space, what you're gonna do is, I think you just do $0, comma. That's a bad output. So now what you could do is you could do man awk. I use this in scripting. Sometimes you forget how to use um, directly. So what you could do is you go in here and let's see. What I want to use is I is include file, L. Okay. Okay, file, exec, O, post, interval, program execution. So what I'm going to do is let me try. Um, what I'm going to do is percentage %s and a comma. Percentage %s /n. Nope, we don't want that. What I'm gonna do is,
Can you use that ampersand sign? 2 ampersands?
okay, 2%.
Yeah.
And then I thought I would just use S like this, right? No. Here, 2%. In quotes.
Yeah, try that. No, that's not it.
Mm, what you do is percent S space percent S/N. Oh no, I don't know why it's not showing up. Okay, so we have this part at least. What you could do is you could use another also. Let's see, 5, and it's giving the numbers here. So let's do the cat text file. Okay, so for this part, let's not waste too much time. I will come back to this. I'll find out what's the correct format, and I'll come back to this here. Okay, so, but in all, usually you use this to just extract one or two outputs here. I'm gonna use the good one here. I'm gonna say number 4. Okay, so this one is better output. You know what, actually, let me clear this and let me do VI sort file, right? So let me delete everything here. Let me go to something like column one space, column 2 space, column 3 space, column 4. Okay? And I made bunch of copied and pasted bunch of lines here. So what I'm going to do is I'll do awk, and then I'm going to say sort here. Okay, so now you see you have a better output here. Now you could also bring back column 1 here and put it wherever you want. Dollar column 1, and then dollar column 2. Then you could repeat the dollar column 1. And then if you do that, see, you could manipulate however you want. You could use this as an output. All right, so let me put this here. Let me see if I could. If I want to have like a bigger space in between, now is it gonna work or not? $1, $2. And let's see here if I could put %s and I'll give a big space and then %s/n. Okay. No, it didn't do that. It brought, okay, so let me remove n here. Do I not do this? Okay, so all you have to do is just add a code and bunch of spaces in here. So if you do like bunch of more spaces here and then the width widens. So this is what you do here. Just don't put anything. Just put double quotes in there and then it will give the output to you. And now, next command is unique. If I type unique, and then if I type the name of the file, what it does is it will remove the duplicates. It will remove any duplicate for it reads this the start of the line, and then it will remove any duplicates here. Obviously, this sort file has too many lines which are duplicates. So it's going to bring in only exact line which is unique to it. So if I go and manipulate in here, if I do vi sort file, and then over here, what I'm going to do is I'm going to just reduce a little bit. And then I'm going to say 4, 3, 2, 1, right? And then I'm going to make a duplicate of that too. So it shouldn't be counting that. And then I'm going to say here a 3. And somewhere over here, I'm going to say 2, right? So now I should only have like four unique lines here. So the idea here is it's reading here. This line is not same as this line, okay? Just because there is a single change in here. So this is not exactly a replica of this one here. So it brings up as a unique. Okay, so this is how it works. All right, now let me clear the screen. So what I'm going to do now is the next command is date. If you type date in here, it displays the date, today's date. And if I type CAL, it brings up the calendar for this month. If you do like cal, uh, if you go like September 2025, it brings up the calendar for 2025. Actually, let's do 21-25. See, it brings up the calendar 100 years from now in no time. So this is a good, if you really want to see quick and easy way to see the calendar, or the just want to jump to a date. Sometimes it's hard on other devices to check it, but in Linux it's very easy to check the calendar date, stuff like that. Okay, and let me clear. If I type W, it will tell me who is logged into the system here. So I see Greg is logged in a couple times here, and Bit. Okay, I wonder why other people are not logged in. But you guys have access, right? Anybody who don't have access, let me know. That way we could do this here. So it will tell you who is logged in at that moment here using the W command. All right. Now the next command is last. So if I type last here, it will tell me the activity is who's been logging in and out of the system here. But if I usually, when you type last, usually you have like activity of thousands of lines. So what I want to do is I want to do last, and I want to do -10. So I want to see last 10 activities. So I see who has been logging in last 10 sessions. All right, now let's type free-h. So when you type free-h, you get the memory information here. It kind of looks weird here. Give me 1 second. Okay. So when you type free-h means human readable, it's giving you the memory output here. So the size of the memory is, okay, this is given here. It's not giving you the correct output. It's actually 2 gigabytes. So it's showing you in 1.7 gigabyte. Okay, gigabyte is a bit different than gigabyte. So we could discuss this later on in the course. Okay, so free, it will tell you how much the memory you have in the system. So this is total memory, how much has been used, how much is left, and how much is in cache. So this is in cache, that means it's held up. You could, there is a way to clear this up, but I wouldn't do it because there may be used by a application. So you just let it sit there. All right, I'm gonna give a 2-minute pause here and see if anybody has any questions.
Could you go over the unique one again?
Unique? Sure. So what I'm gonna do is I'm gonna do sort here, and then I'm gonna say apple, pineapple, grapes, broccoli. Okay, then I'm gonna do YY, and then I'm gonna make some duplicates here. And then here I'm gonna change like Apple here, and then I'm gonna bring Apple on the end. Okay, I'm gonna do this here, and then over here I'm gonna get rid of grapes. Okay, and then over here I'm gonna write like orange. Okay, so you could see here like all these are at least we have like ones which are multiple identical lines here. So what is gonna do here is when we do unique, um, mm. So if I do cat sort files, okay, let me do it from the top. And then if I do unique, mm, let me clear this. Okay, so this file you're seeing is output here, right? With everything inside that file here. And you see, oh, so these are too many lines here. I don't want to see all these lines. It looks like duplicates here. I just want to see which ones are not duplicates. So you do is UNIQ, unique, and then you do the name of the file. And what it does is
Yeah,
it scans the line, and then anything which is different, it will bring it to you.
got it. And
So
does it work the same with numbers too?
yeah, it should.
Okay, cool. Got it. Thank you.
And then if you want to send it to the file here, remember our redirector from last week?
Mm.
And then you give it to a new file name, new sort file. Okay, now a new file with the name new sort file has been created. And if you cat that, and there you go, the output is here. See, in only few keystrokes, you sort through a file and you have a good output at the output you like, and you send it to the file already. So you have a new file with the output here. So for same task, if you want to do it in Windows, you have to open the file, copy what you need, and then open another file and then put it in there. So you see how this things is, uh, a bit efficient, I would say, bit efficient compared to Windows environment.
Thank you.
All right, so moving along. So what I'm going to do is the next command is a du command. Du command is a disk usage command. It will tell you the size of the file here. So in Linux, if you're working for a while, you would get like, oh, I mean, it's a fact of a life that the space on your phone, the space on your computer, it gets filled up, right? So you need to find out which file is taking the big space. So for that, what you could do is you could run this command um, du hyphen h and a period. Well, can somebody remind me what is a period means here?
The current directory.
I'm sorry, I didn't hear you.
The current directory.
Yeah, very good bit. Present working directory or print working directory. So when I type this here, okay, so it's going for all the hidden files here. Let's ignore that. Mm. So here, the size of the disk place we are in is 5.2 megabytes. And then what it's doing is it's also bringing up all the files which are in different folders here, okay? White hat, red hat. So in this file, there is, okay, so the directory itself is 0. There is not much in there. So in here, there is a hidden file here called Samba. And so why I have so many hidden files here? Mm. So I have some of these like config and local files here. I wonder if I could, okay, these are like extra files which are there. So let's ignore this here. Okay, so what I'm gonna do is let me clear this screen. I do ls-l here, and let me just move all the files here, mv asterisk, that means move all the files to Red Hat, okay? So if I do ls-l trh, all the files got moved except the Red Hat itself. So Red Hat is still there. Okay, let me clear this. Now what I'm going to do is du-hx period, and then I'll hit enter. So in reality, this file is, let me remove that. This directory is only 20 kilobytes in size there. It's meaningless. What I'm going to do is I'm going to copy a file from system here and we could analyze that, okay? cp slash var log messages, and I'm copying to this directory here. Okay, remember this is a command I showed you, right? cp. What kind of path I'm using here to copy the file? Anybody?
Direct.
Direct. Yeah, what is it called?
Um, Full path or direct path or
Absolute path.
absolute. Absolutely. There we go.
Yeah, very good. Absolute path. I'm using absolute path to copy that file. I'll explain you what sudo is a bit later. Now I'm going to run this command, du command. So now I have the file. I'm checking the name of the file in here, and then all of a sudden the file has skipped from 20 kilobytes to 392. Why? Because we copied this messages file here. Sometimes you could see ls-ltrh, and you could see the size of the file here. So what I'm going to do is I'm going to bloat this file, a big file, and see what happens, okay? Cat messages, and what I'm doing it here, I'm creating a new file, messages, and I'm sending it to the messages one, okay? So that I could do so before that, let me sudo chmod 755 messages. So what I'm going to do is cat messages, and then what I'm doing is, if I do double quote, double greater than, and then I'm sending it to the messages file, what is double greater than going to do?
It's gonna append it to the end, or it's gonna
Yeah,
erase it. One of them append it.
yeah. Correct. It will add it to the bottom of the line. Now this time the file message one doesn't exist, so it's going to create one. Okay, if I do WC messages one, I have 4,237 lines. And then if I do it again, and all of a sudden I have double, see it's doubling in size. I'm just running this so that I have a bigger size of the file so that I could show you to pinpoint like the fat file which is taking up space here. If you do ls7ltrh, and you could just eyeball it and see here, this is a 4 megabit file. So normally the good command you do is du -hx, and in this present working directory do -- max depth equal 1. Okay, so what it does is it goes into all the directories only. It doesn't go directly. I'm sorry, it doesn't go into the directly. I'm sorry, not directly. Directory inside directory inside directory. It's going to go into only one level. It's not going to go into multiple levels of the directory if the directory has multiple levels, which in reality it does in a real world scenario. But here we're just going one directory deep. So here you see here, okay, this file is nothing much and this file is nothing much. So the majority of this is in here, the present working directory. So what you do is you do ls-ltrh, and you see, oh, there is a culprit over here. So you look at the permissions here and say, hey, Zafar, your file is taking up space, clean it up or do whatever you want to do. So what they do is sometimes they have a junk file sitting around, they'll clean it up for you. All right. So this is the culprit file here. And so what I'm going to do here is 1, 2, 3, 4. So I'm going to go like this here. Okay. Du is command, and -hx is human readable, and the period is pwd, and maximum depth is how much down the is going to drill down on the directory. Um, okay, so usually just stick with this -depth equal 1. That formula is pretty good, is so you know which directory you want to do it and check up on that. That way it gives you the faster results. All right, so moving along. The next command is top. When you do a top command, it gives you a bunch of output here, right? So here you have
Why is yours more colorful than mine? Mine is in like black and white, and yours has the yellow as well.
Yeah, what I did was I changed the color scheme here. If you
Um,
go and change the color scheme, go into colors here and default foreground and go modify.
mhm.
I have a bit of eye problem, so it's easier for me to see this.
Got it.
So you could change it around and then that way you see him. So the important thing you're looking at here is the task here. So there are like 176 tasks here. These are like 176. Anything that is happening is a task. Like you logged into the system is one task. So it's gonna show up here. And how many tasks are running here? One task is running, and the other 194 are sleeping tasks, and one is in stop state. So it makes sense here. 194 plus one running plus one stop, 196. Okay. Sometimes you see a zombie process running. That means if you delete a file, it will take a little bit for the system to understand that files has been deleted or it's in the process of deleting it. So it will put that into a zombie. And here you see the memory information here. And this is the total memory, how much memory has been there free, and how much memory has been used, and all this stuff here. And also you see the CPU utilization, okay? The important thing is over here, you're looking at the CPU. CPU activity. If you see CPU 97.4, this means CPU is idle. Okay, so what this means is 97.4 ID. This means that 97% of the CPU is central processing unit is idle, means it's not working. I mean, it's just sitting around. Okay, idle means not busy. If you see CPU around 20% idle, that means 80% of CPU is being used. So that could be a cause of concern why CPU is so high. So you could come here and take a look here. So over here, you see these processes are, you could see the processes are being used here. So PID and stuff. So it gives you this PID here, but look for the idle time here. Idle time is only, not idle time, the use time. Use time is like only 1% is being used like only 1%. So these are not the cause of concern here. If something is being used like 50, 60%, one process, you have so many processes in the system. That's why it's going up and down here. Here's the reality. If the system is not doing anything, just sitting there, but system is up and running, right? So it is doing something. When the system is not doing is when the system is not doing, when system is absolutely in shutdown mode. But right now, if it's doing anything, that means it's turned on, means it's doing something. All right, so that way you could, when you're doing troubleshooting, you could pinpoint it here. Oh, look like 3.03% is nothing. if somebody says, hey, Zafar, your process is taking too much CPU, and you take a look in here, and it's like something like this, under 1%, even at 50%, it's not taking much. Right here, it's taking only 7%. So you could tell them, hey, my process is not taking as much space. So you have to contact the application team. All
What what did the like the US, the SY, the NR, the ID, WA, and HI and the SI stuff mean at the top for the ST stuff? Like on the CPU like row, like going across like the US, SY,
right.
NR, yeah, all that. Yeah, what does all that mean?
So this line, you want to know this line is what it's doing here, right? So usually this part is, so let me copy this here. So US means like uh, this is a user space, okay? CPU. It's using the user space. It's like whatever the user is logged in, they are using that percentage of CPU.
Mm,
Okay, so there are like 3 or 4 people logged in, and including root. This is how much they're using. Okay, and then this is a system is being used. System is using about that percentage of the
CPU.
CPU. Okay, and then this is there is something called nice priority. Um, so usually that usually is at 0. So you could ignore that one. This one I explained you. This is like the processes which are using this here. Okay, and this one is the wait time. That means if the system is using the hard drive input and output activity. So this could be hard drive input and output activity, or it could be the activity of a network and stuff. So if these are low, then the system is working very good.
Mm,
And and this one is, if you are getting a hardware interrupt, back in the day, it used to be the interrupt called uh, LPT port and stuff like that.
mm,
Um, so I forget. This is more related to hardware interfaces.
mm,
All right, and so this one is software interrupt. That means software interfaces. Um, so I forget what it used to be. This interrupt back in the day, but these are usually ignored. And also, this is like time. How much time this is being up here? Usually, even if the system is running high, when this is around 50%, all the other ones should remain low here, especially the last four.
gotcha.
So the important thing is you concentrate on this part here. CPU, if the CPU is high, then there is some issue.
Okay.
Okay, and let me quit here. And the next command is lscpu. And when you type lscpu, it gives you a lot of information here. But the only information I am interested is how many CPUs the system has. So this system has only one CPU. I need to increase the CPU to 2. I don't know why. I thought I put down 2 CPUs here, but it's showing only one. So normally the smallest you could go is like, the good rule of thumb is have 2 CPUs on your system. Okay, because later on, well, this is just a demo system, but if it's a database system and stuff, you would see like a 64, 128, a lot of CPUs in there. So this part, you're gonna be just looking at this much here. Mhm. Okay, and all right. So the next command is which, right? I'm gonna go back to the main directory. If I type which, it's gonna come back here. So I'm gonna type which pwd. So actually pwd, when you type pwd in itself, it's a little program. So when you type pwd, so which is the command you would use to see if it's running, if that application, if that thing is installed. If I type which Firefox, so the Firefox is not installed. Okay, we'll come back to this when we're going to install some application here, okay? But for now, just go with this information as of now is it will tell you, this command will show you the location of the command or a package, also good indication if the command or package is installed, okay? So PWD is installed, Firefox is not installed. So you could tell in the system that Firefox is not there. All right, so it's 9:30, halfway through our class here. So let's take a 20-minute break and we'll be back at 9:50 Central Time, okay? And the break starts now.
Excuse me, sir.
Yeah.
Can you also use Command -V to see if the application has been installed?
Um, dash P as in Papa.
No, Command -V. Like just type in command, the word command,
Oh, command.
-V, and the -V,
Mhm.
and then the app, whatever the application is.
Okay. Yeah, that is a very good thing.
Yeah.
And then you do Firefox. Yeah, no output means it's not installed. Okay. All right, so let's come back at 9:50 and we'll go from there. Thank you, everybody. All right, thank you. All right, so now I'm gonna show you when using a command how you could use pipe. All right, if you do clear and if you do like a pipe here on your keyboard, right above the enter key, there is like a slash, and above that there is like a, a small vertical line, right? That's called pipe. Okay, so we'll see how you could use pipe to manipulate the output. Okay, so what I'm gonna do is so it's called pipe, just like a pipe. And let's do cat sort. All right, so what I'm gonna do is I'm gonna say like cat, and if I do like sort here, I get like a regular output here, right? So what I want to do is I want to grab for something. Um, oh, see, this one has all this stuff in there, right? So let me do something here. Let me do VI, and then I'm gonna say fruits, and then in here I'm gonna say apple, apple, and I'm gonna say blueberry. And I'm gonna say orange is citrus. I'm gonna put down a couple times there. Then I'm gonna say strawberry only once. And then I'm gonna say pineapple few times. Right, I'm gonna save and exit. And if I clear the screen, and if I do cat fruits, what? Oh, see, I typed wrong. Cat fruits, fruits. All right. So I have this here. Now what I want to do is I want to add a pipe, and then I'm going to use grep, and then I'm going to use apple. So what happened here is the system is looking for just this pattern here, apple. So now there is an apple and pineapple, so it's going to bring that to you. Okay. Now what you want to do is you want to do bring the line back up, and then so you want to do the filter of the result. You're gonna do the pipe again, okay, and then you're gonna do grep, and you do pine. So let's see what happens here. Okay, so what it did was it's gonna in this result is gonna only look for this part here, pine. So it's gonna ignore the lines which doesn't have pine in it. It's gonna bring only the line that has pine in it. So what you are doing is this is a primary command, this is a secondary command, and this is a third command here. So I don't so there is no limit how much you could add the filters in here. Okay, so thing is you have to run it like this. So here, if I say like grep hyphen uppercase A, so remember this is case sensitive. So if there is a uppercase A here, it's not gonna bring the result because there is nothing which is matching exact format like this, exact instance like this. So for it to be able to pull, what you could do is if you don't know exactly what you're saying, but you say hyphen I, ignore the case, then it will bring up that. And then you could continue on adding the pipe here, grep, pineapple. So in here, if I do uppercase P, but if you forget to add ignore here, then it's not going to bring anything. So if you do hyphen I, then it will bring the result here. So did you get here -I adding -I gives you the it gives you the output which it will tell you you could ignore. So that is how you use this command here. This command is very common. You would be using this all the time. There won't be a day you won't be using grep, cat, pipe. Most of these commands are there. All right, now the next command is gzip. Gzip means zipping the file. So if I do ls-ltrh, ls-ltrh, and you see, okay, so we have this file here. So what I'm gonna do is I'm gonna cat I'm gonna make this file a fat file. Okay, input file is output file. Okay. Okay, I'm not worried about that. So I'm just making this file bloat. So the size of the file is now 6 MB, right? So I want to make it even bigger here. I want to go up to 1 gig so that okay, and then if I do okay, that should be good enough here. It's I mean 1 gig is very far away, so I have it at 11 megabytes here. This file, just imagine it's too big. So there is a built-in command called gzip and the name of the file, and you hit enter. It takes a few seconds. And if you do ls7ltrh, here's the file here. The file is, it will get the extension .gz. Okay, and the size of the file is now reduced. You see the size of the file was how much? 11 MB. Now it's down to under 1 MB. So it reduced itself to the 10th. Okay, so when you do gzip file 1, messages 1, messages 1 is now at under 1 MB from being 11 MB. You guys noticed that, right? It was 11 MB before we gzip it. Now it's at under 748 kilobytes. That means under 1 megabytes. Okay, so how do you unzip this? You unzip this using a command called gunzip. When you do gunzip, it restores the file to its original mode. So I'm going to clear this. I'm going to say gunzip and messages. And it takes a bit here. And then if you do LSF and LTRH messages, one, see, this is the output here. The size is 111 MB now. It's back to 11 MB. Okay, now I'm gonna put it here. So it was 11 MB, it went to 768 kilobytes. Now it's back to 11 MB. So the model of a story is you reduce it, and then it has make sure it gets the extension. Okay, so another point is adds extension .gz. Okay, it adds this extension there. That way it knows or it distinguishes itself from other files here that this is a compressed file. All right, 2-minute pause. Let me know if you have any questions here.
Yeah, is there a way, once we zip it up, is there a way to view it? Because like the cat and the tail and the head stuff, they don't work when you zip it up. So is there a
No,
way to still view it or not?
no, you have to unzip it.
Okay.
Now let's get out of here. And if I do ls here, I have one folder here, right? So I want to send this folder to somebody, but I'm unable to do it because folder has individual files here. So what you have to do is you have to make it as a big file. So it's called tar. Tar means you're making it, bundling it up. Once you bundle it up, you could make it as a single file. Then you could send it out or email it out or whatever you need to do. So for that, what you're doing is tar, and then the command is hyphen C as in Charlie, V as in Victor, F as in Frank, and you give the name of the folder. So what it does, it keeps the existing folder and it creates a new folder with the extension .tar. Actually, you have to give it manually here. And what it did was it took all the files inside and made it into a little package. So if you break this down here, 1, 2, 3, 4. Okay, and then the switch. This is the switch you use. This is the destination. And it's kind of reverse here. And this is the source. It's kind of usually a source and a destination comes before destination. but it's a bit different here. And you could definitely use this as it could be the file could be somewhere else, and then you could do this in your present working directory. So now, what is CVF stands for? Okay, C means C is to create. V is verbose. That means it shows the activity. Show you on the screen. What is being tar? What does that mean? When we run this command, it showed us what are the files being added to the file. Yeah, so this is what verbose means. Okay, and then F is for folder. Source folder is this one here. We're telling tar to create, and verbose. If you don't see verbose, it just holds it for a few seconds and then comes back. You don't see any output here if you don't have V in there. But usually it's a good idea to see V in there. You could see the activity. Normally, if you're doing like a big chunk folder, like 2 gigabytes, you would want to see when it started, when it ended, and if it's missing any files here, so you could see the output, which files are being tapped. All right, so now what we could do is clear the screen. Then what we could do is we could run the du command also. Du-h, and we could give the name of the folder. Okay, that folder is 12 megabytes. And let me give the tar here also. Tar here also is 12 megabytes. Okay, at this moment you could email them, but now this is still, in reality, the size is big, right? So what you could do is now you could do gzip. Now you could do gzip, redhat.tar. So what will happen is it will add the extension here .tar. So if you do ls-l and then asterisk, and then, okay, no, don't do that. Do ls-ld, then what you want to do is, what is the name of the file? Okay, I forgot. Okay, Red Hat. You do ls-ld and then asterisk, and it will give you the size in here. So now you see here, okay, if you want to see it, you add RTH, ls-lt RH, and you see the size has gone reduced here. It used, the size we saw earlier was 12 MB. Now, okay, I should have captured that size. Okay, redhat.tar .gz. Okay, and then Red Hat. So the size of the folder Red Hat is 12 MB, and then the tarball for that same file is 776 kilobytes. That means it is 10th of its original size. Okay, 2-minute pause. Any questions?
Yeah, can you also do a file along with the tar.gz file. If you type in the command file and then the GZ file, it should
File?
give it should give you the original size as well. Yes, a file and the original, yeah, .gz. Oh, you got to do the .gz. Yeah.
Yeah.
Mm.
I had a question as well. With the tar, is the tar supposed to copy the files into the tar or move files into the tar? Because I created a couple of text documents and I was like tar, but then the original ones are still there. So does it copy the files or does it just move them?
It copies it because it
Okay.
keeps the original
Okay.
folder, the files in there. You could still go into that file and you see the original folder in there.
Okay. Got it.
So it makes a copy and creates a .tar. And then when that tar is not good enough, you do .gz.
Yeah.
Okay, so now if we want to untar this, okay, so and then you receive this from somebody and you want to untar this, right? So what you want to do is you want to run this command. Let me clear the screen. So you run the command tar. Now this time you do x. This time around you do x vf and then the folder name .tar. Okay, and if you do ls-ltrh, so actually what it did was it overwrote in here. So let's get rid of this. Suppose you don't have this file, original folder here, Red Hat, rm-rf Red Hat. Okay, and then if you do ls-l, so what you're gonna do is you run that tar-xvf command. Okay, now if you do ls-l, there you go. All of a sudden that folder is back and it keeps the original also. All right, anybody has any questions? And what was the command? Okay. Okay, so XVF, what it is X stands for extract, okay? V is for verbose again, and F is for folder. Did I put down folder for the other one? Yeah, folder. All right, so that is what you use now. I Anybody, any questions? All right, let me give a 2-minute pause and then we could continue on. All right. No questions means we could continue on. So the next topic is going to be stat. So we'll see the stat of a file, okay? So what stat does is, if we do stat, and then let's do I type stat and then name of the file here. So what it's giving you here is the bunch of information here. Okay, so first of all, it's giving the name of the file, okay? And then it's giving us what is the size of the file and how many blocks each file is taking up. And so let's see if I multiply this with this, it should come up. Okay, hold on. So 15,1,552 times 4096. Okay. That's not the correct. Is it? One block is 4096. And then it's taking up so let's see here, 792039 divided by 4096. That's not correct either. All right, I'll get back to you on this, what this part is. All right, so next item here is inode. Okay, remember earlier we talked about LS-L, right? Inode. So this is what the inode is. So this is the name of the, think this as a social security number for this file. So inode number is, every file has an inode number, right? And this is what the inode number for this file is. When you do stat, it's showing inode number also. Here, you see device. Device means the location of the disk, the location where the file is sitting. That's what is called a device. And these are the permissions here. We're going to go into great detail what these permissions are. Okay, and then UID and group ID is the IDs of the user who created this. Obviously, if I created this is my UID and group ID. And this is context. This means this is SE Linux. There is one topic, SE Linux, in there where it is related to the security of a file and the file system. So when you see this here, context means this is a SC Linux context. I have to explain that in great detail what all these things are mean. Okay, so that is there. But here, the other aspect here is the activity related to this file here. So down here is birth. That means when the file was created. File was created like 10, 11 a.m. and at 29 second. And then the rest of this part here is milliseconds. Okay, so the Linux system, it captures the time up until the billionth of a second. Okay, when you have, how many are these here? 3, 3, 6, 3, 9. So when you have a 9-digit, that means it's up to the billionth of a second. Okay, and so it has like timestamps. When was it created? When was it changed? When was it modified? And when was it accessed? So you have all these timestamps on the system here that will show you. And this is called a metadata. It's recording all this information here related to it. Normally you don't see it, but you have to use some commands to see the information here. So now I would put down some characteristics of an inode. This is just informational here, so you could like read it on your own time. So what inode is, so this is inode, right? And the inode number for this file is this here. So this number, it is a table on the disk that holds the file information. So who's the owner, group, type of the file, is a file or a directory. And then its permissions, date and time, a modified create access, number of links and blocks. So let's take a link here. It says the file has one link. Okay, so why would a file has one link? Every file has a link it's to itself. That's why there is one link. Everything starts with one link. Your body is a link to your soul, right? Just remember it like that. You are a link to yourself. So every file has a link. All right. So that is there. I did explain you guys about this thing here, right? Inode, how to search for inode, right? Using the find command.
I don't think so.
Now let me go on to the website. Okay. Okay, yeah, here. Inum. This is the inode number here. So what you do is you use the find command and then the location where you want to be. You could put a period also. And you use inum and give the inode number. Okay, that way you could find the file using the number. So moving along.
Yeah, what was when the in the context part? You said it's ASIA Linux. What was the context part?
Yeah,
Um,
SE Linux, SE Linux.
ASI. What is that? Like, how do you spell it?
Yeah, over here, I'm gonna put it down. SE Linux.
Oh, isn't that like for cyber security type stuff?
Yeah. Mhm.
Oh, okay.
Security of the file.
Yeah.
Okay, so a lot of security is already built in. Usually, if you're copying like file from one system in your one system to another system, this is where the SC Linux comes in because the other system might have a different security privileges, right? So when SC Linux sees that file, it applies the system security of this system to that file, the foreign file which is coming in. So yeah, so that is what it's called a SC Linux is a security layer built into the Linux. It's already built in. But we don't deal with that as much, but we'll see how it goes. All right. Um, and did I talk about the links? Okay. Now I'm going to talk about the links here. Okay, because the topic came up. Okay, link is the command you use is ln. Okay, and there are two types of link. One is a hard link and a soft link. Okay, and there's two type of links, hard link and soft link. And these are the characteristics of a hard link here. So I'm going to explain that to you. So hard link, it has the same inode number, and you have to provide the source and destination in absolute path when you're creating a link. Okay, so let's play a game here. Let me remove. So I'm gonna get rid of this tar stuff, okay? And then if I do ls-l, so what I want to do is I want to make a link of fruits in the present working directory here. So how I'm gonna do is I'm gonna clear that. So what I'm gonna say is I'm gonna say ln and then fruits. Okay, and then I'm gonna give it a name here, which is called fruits also. Let me try this. If I could say fruits, if I could give it a different name, okay, maybe I could give it a different name and it survives. and I'm going to give it fruit-1. Okay, so now if I do ls-l, so we have fruits-1. If I cat this fruits-1, and if I cat the hard link which is inside a different location, okay, both of them has the same output. And then if I go vi and then here, and if I go to the bottom of a file and then say I am adding this line from hard link, this is test, okay? So if I just do it in the same directory here, present directory, cat and fruits-1, I have added this here to this line here. All right, so this is, we know we edited this line here. But since we made this as a hard link to this file, okay, this is the hard link to this file here, okay? Okay, these two are hard link. They're linked together. So now, wait a minute. Even before that, what is the reason I'm making a hard link, okay? Do you guys know why I'm making a hard link?
So you could edit a file that's probably in different directories, but edit the
Yeah,
same file.
yeah, very good. So the file is in one place, but you could definitely edit it. It has a lot of other uses too. So let me just reposition this one here. Okay. Now here's the moment of truth here. I edited this file here, fruit-1, and then let's see if this got updated. And it did. You see, we didn't go and update this line here, but we updated this line thing here, and it got updated here. And it's vice versa. If you update there, it gets updated here because it is acting as a duplicate. If I do ls-i and then this, you see the inode is the same. And if I do ls-i and then the file which is sitting somewhere else with a different name, and it has an identical inode. Okay, this is a lot for you guys. So any questions? I'm going to give a 2-minute break, and then I'll ask you if I have any questions, and I'll explain if you need to be one more time.
Sir, so essentially, the link is hard link is just a shortcut of it, right?
Um, Actually, it could be a backup copy also, a hard link.
Cool.
Now, if I delete hard link, if I delete one link, the other link will survive. The other will survive. We're gonna go and delete the original one and see if the new one is gonna keep itself in there.
So in other words, if I have a Windows and I have a shortcut on my desktop, but I have it on my program user, whatever, program files, that shortcut will remain there. But if I remove it, the actual program files app document or whatever, when I click on that shortcut, it will just say something like,
Yeah,
if I,
the shortcut will not work. Over here, it will work.
but over there will work. Okay.
Yeah. So, any updates? Any updates on either side? On either side, updates both. If one is deleted, other survives with data. Okay, so now remember this is the original file here. So I'm gonna get rid of that file. I'm gonna say rm-rf, and then I hit enter. Okay, if I do lsf and I that file access no such file or directory here. But if I do my local file here, the file is still there. And if I do cat here, I'm able to cat that file, no problem. See? Okay, so I forgot to capture this part here. Link. Okay. So in here, and while creating hard link, you must use absolute path. Um, you must, no, not necessarily. No, oh, this is not necessary. But you have to provide the source and the destination. Okay, source and a destination. It could be in any location here, and it could be a different name. Okay. All right. Gonna give you a 1 minute pause here. Anybody has any questions?
I did have a question from before. How do you install like programs? Because I know on Ubuntu you use APT, and then I think with Red Hat stuff you use like Yum for DNF. Because for example, when you were showing the top stuff earlier, there's also a other program called HTOP and another one called BTOP, which are kind of a bit more in depth. And I was trying to install them, but like the commands don't work. And even I tried to do the sudo, and it said that it would send you a notification. Yeah, how do you install like programs on the Red Hat
Mm.
servers?
So you are, what are you using? Are you using on the system I provided, the one you have?
No, I'm talking about yours. Yeah, this one.
Yeah, you don't have a sudo rights. What is the error it's giving you?
It said like sudo like it basically said it won't work, and then we'll notify the administrator or something like that. So it
Yeah.
basically will notify you basically.
Do you have a local system?
Um, I'm gonna I'm gonna switch it up. I'm about to partition my drive, and I'm gonna switch to like partition one for CentOS and one for Windows. So I'm about to get back on it, but I use Linux a lot for like myself, but I got to get like back to it now.
Yeah, so once we're done with this thing here, then I'll help you guys install local Windows, sorry, local on your machine. That way you have full access. Okay.
Oh, boy.
And
Okay.
then we'll have a session where you could download the virtual machine and do all that, full administrative privileges you have.
Okay. Sounds good.
Okay, so all right, good question. Moving along, let's see. Okay, any questions about hard link? Okay, so this is hard link. Then let's move to soft link, okay? So okay, so uh let's see what time is it? 10:49. Okay, so the soft link part, I'm gonna just put this here, but I'm gonna explain this next week, okay? Because soft link is bit hard to understand because soft link uh it doesn't have same thing as hard link, and you cannot make the hard link for um cannot make hard link for folders, but you could make a hard link soft link for folders. So I'm gonna stop here, and then uh, please use please use whatchamacallit, the thing I'm gonna upload, and then also what I'm gonna do is um, I'm gonna put down in here some assignments, okay? I'll put down assignments. That way you could do assignments, and that way I could measure how you guys are able to grasp what I'm showing here. Okay, so please be content with what you're learning. Give me feedback if you have any questions. I'm here to help. If not, we'll continue next week. So everybody have a good day, and try to work it out. And if somebody, please, if you are getting stuck somewhere, please raise your hand, ask in discussion, or ask me. I'm always there to help you, okay, throughout the week. All right, guys, have a good week,
All right, thank
fun
you.
week. All right, bye.